Hey everyone, welcome to the next segment in our video series. This video will focus on the direct effects that exercise has on our respiratory system, and then we'll get to the last component. I decided to split them up, where we'll discuss how training effects can occur for our respiratory system. So we're going to start with this by looking just at this graph, and it actually explains quite a bit within it. So if we look at the y-axis here, you can see that we have pulmonary ventilation in liters per minute. And then on the bottom, we can see that it denotes 3 different phases before, during, and after exercise. So before we start exercise, when we're at rest, we have about 20 liters per minute of ventilatory exchange volume, or that's the rate, sorry. And just before or just as we start exercising, we'll notice an increase in our respiratory rate. And this is part of our psychomotor drive to ventilate, or our conscious thought. So when we start thinking of exercise, and I shouldn't say just conscious thought, but if we just start thinking about exercise, our motor cortex and different parts of our higher levels of thinking will start increasing our respiratory rate a little bit. But right as we're starting to exercise, our motor cortex will provide signals to our ventilatory center. So that includes our medulla and our pons, and that will increase our respiratory rate. But as well as when we actually start moving, our muscles have certain nerve receptors in it. If you recall, they're called mechanoreceptor, a type of mechanoreceptor. They're called proprioceptors. So they're able to, when our muscles start moving, they'll send a signal to our brain to start increasing respiration. And so that's all happening in phase 1. Okay, so that increases, there's a little plateau, and as we enter phase 2, that's more when we get into our what's called steady state exercise. We're not there yet, that's phase 3, but we're starting to increase and get to a point where all of our peripheral systems, so sensory sensors in particular, are chemoreceptors. So that, remember that chemoreceptors measure or respond to different chemicals. So in particular, this would be our chemoreceptors looking for carbon dioxide and hydrogen, protons or acidity. And what they'll do is refine our ventilatory rate to match what our exercise, or try to catch up to what our exercise is. Anyway, so we still carry over these previous factors as well. So our motor cortex, our proprioceptors, but now we're adding in chemoreceptors here for phase 2. And then when we get to phase 3, that's when we have hit steady state and have been in steady state for a while. So we're not just adapting and reaching steady state, we're in it. And what happens here is we continue to fine-tune our ventilatory rate based off of more central receptors as well as our periphery receptors. So that would be more to do with chemoreceptors on our aorta, and as well as our cerebral spinal fluid and receptors that are noting change in pH content there. Okay. At this point in time, because we've been exercising for a while, temperature might as well increase or influence an increase in respiratory rate a little bit, or to help match and refine the rate that we've hit here. And then once we stop exercise, that creates its own stimuli where the removal of the stimuli originally, so carbon dioxide and hydrogen protons are the main drivers. Once those are eliminated, as far as accumulating and increasing our ventilatory rate, that's when we start seeing a decrease in our pulmonary ventilation. Okay, so we remove those signals. Yeah, so at rest, just to kind of touch on carbon dioxide, or the partial pressure carbon dioxide, is what sets our rate at about 20 liters per minute. And then, yeah, as we exercise, yep, we touched on all of those. So during our 3 phases, here are the main points I just written out for you. And again, removal of feedback allows our body to return to homeostasis, or the same ventilatory rate for a pulmonary ventilation as we were originally at rest. So that's great if we do sub-maximal efforts, but something different occurs when we're at near maximal exercise. So if we get above our 50 to 60 peak oxygen consumption, so VO2 max, so 50 to 60% of that, which is pretty common, we'll have passed phase 1 to 3. So if, again, just to see that on the chart, that's here. So we've kind of reached this steady state, but we start continuing to increase our workload and therefore need to increase ventilation. What we'll see is we get this disproportionate response to our ventilatory rate. So the amount of oxygen that we're pulling in is sufficient even past this period, but what happens is we still see a significant increase in ventilation. And the reason for that is increased acidity. Okay, so our working muscles create lactic acid and create an acidic condition for our body and our blood, right? Carbon dioxide does a similar thing, but we have these metabolic byproducts that create a lower pH. So a decreased pH or an increased acidity once we get above our lactate threshold, okay, which for some is around this point, but for others it's a little higher for trained individuals. So again, those chemoreceptors on our periphery pick up this increase, and because of that, the disproportionate increase in ventilation that we experience near maximal exercise, again, that kind of hyperventilation, allows us to exhale excessive carbon dioxide that builds up when we're doing above our anaerobic threshold. So at this point in time, to put it in a bit clearer context, hopefully, we're not in an aerobic zone anymore. So we're not purely relying on aerobic respiration to meet our needs. We therefore are now adding in anaerobic respiration, which increases a lot more of these byproducts. So again, to be clear, we're getting enough, or we're maximally meeting our oxygen consumption needs. What happens disproportionately here at this point is we're trying to get rid of byproducts. So another way of saying this is you're getting a sufficient oxygen, but you need to expel and get rid of the waste products because you're making too much of that. Okay, that's why you increase in breathing. And I think that's a really important thing to remember, because that's a little counterintuitive to what most of us might just know or feel like we believe we know from what we've heard from previous conversations, discussions, or even feelings of when we've worked out really hard, right? It feels like you want to try to breathe in more oxygen because it feels like you're out of breath, but really what you're trying to do is just vent out carbon dioxide. So you'd be better off in those situations to feel about fully forcefully exhaling rather than trying to suck in more air. Okay, good. So next up we have the effects of training on the respiratory system.